Hello, welcome back to this channel, Biblical Validity, where we look at how science, historical scholarship, and logic all point very nicely, very well toward the validity or the reliability of the Bible. And it was really about maybe 5 or 6 years ago, I started looking at the science behind all this and started realizing there's a lot of evidence out there that really points to the Bible is actually working, actually being true. And that flies in the face of everything we've been told for generations now. How the Earth is 4.5 billion years old. The universe is 13.8 billion years old. It all started in this Big Bang, and then evolution kicked in somehow, and here we are. We came from single cell bacteria up all the way up through the apes up to humans. All right. Well, so most of the world believes that. Okay. And so I'm one of those nutty people that really thinks the Bible got it right. And there's a lot of other reasons which I could talk about. But anyway, let's go on here. Day 5 of creation, and kind of starting to wrap up the 6 days of creation. And it's another amazing day for creation. And so, see, it starts off, and God smiled and said, "Let there be," the Fourier series, "let there be music." And he also created the viola. All right. No, that's not how the Bible says it. Okay. But that's an inside joke. If you're, for orchestral musicians, they would get that because the poor violas, they get a lot of um, a lot of ribbing, I guess you might say, in the orchestra for various reasons, which I don't need to go into. But anyway, violas are wonderful, by the way. They're just a little larger than violins, and they play a bit lower than violins. I think that'd be a fifth lower. C, G down to C. I think that's the fifth lower. Anyway, what does it actually say in the fifth day of creation? On day 5 of creation, God creates all the animals in the waters and the seas, because he mentions both waters and seas. So presumably that could be lakes and rivers, streams, um, and as well as all the birds. And it's an interesting idea to think about. Were the original waters fresh waters? And I've been looking into that. And of course, almost anything you find on the internet is going to claim the waters have always been salty. The oceans have always been very salty. But there's some ways to look at that. So I may talk about another day. And anyway, the so here's how it goes. It starts with verse 20 in chapter 1 of Genesis. And God said, "Let the water teem with living creatures, and let birds fly above the earth across the vault of the sky." So God created the great creatures of the sea and every living thing with which the water teems and that moves about in it, according to their kinds, and every winged bird according to its kind. And God saw that it was good. Then it continues here. God blessed them all and said, "Be fruitful and increase in number, and fill the water in the seas, and let the birds increase on the earth." And there was evening, and there was morning, the fifth day. All right, so as you can see, I join you from the beach with a bunch of seagulls in the background. Actually, that's a picture I took probably at Clearwater Beach a couple of years ago, and I grew up with, with seagulls. But even my part of the country I live in now, one of the most amazing things I heard here when I first moved here was, "Those are seagulls. What are they doing so far inland?" Anyway, they don't just live along the ocean apparently. And I just noticed that sand kind of matches my hair, doesn't it? All right, well, all right. So let's look at the water life first. Mostly we think of water life as fish, but yeah, there are also invertebrates such as crustaceans, clams, squid, octopuses, and many others. There's lots of stuff out there that are animal forms that are not fish. And I believe they are invertebrates. They don't have vertebra like we humans do, mammals do, or fish do. We don't have backbones. They don't have backbones. I get that right. All these breathe in water through the gills, and the lungs extract oxygen and exhale carbon dioxide. Now, I know that it's very possible. I'm not an expert in all this stuff. There may be some exceptions out there. Don't get too excited if I overgeneralize unintentionally. Um, are there gills inside of jellyfish, for example? Is that how they breathe? I don't know. I didn't look it up. Are the gills inside, I don't know, shells, clams, for example? I have no idea. All right. So, but generally fish have gills. And there's one fish, I think it's called the opa, big kind of a round fish. And I believe it has kind of a hybrid lung and gills. I read that somewhere. And the funny thing is that when I read about the opa, which I thought was very fascinating, it actually breathed a little bit of water, air also. The next day at the store, I saw in the fish department, opa. I should have bought it. I could have tasted what that fish was, but I haven't seen it ever since. But anyway, there's so much diversity of life that I run the danger of missing some exceptions, okay, in these videos. So don't be too hard on me. I'm kind of generalizing, but also willing to admit that there might be some exceptions to what I'm saying here because I'm not can't no one can be an expert in all these sciences, okay? And all right, now the evolutionists would have us believe that at some point fish started growing legs in order to come up on land, as well as replacing their gills with lungs in order to breathe air. Now, I don't know exactly how they would argue this, but they have to go from fish to land, and somehow. So, uh, gills have to turn into lungs at some point. Uh, you know, they have to start growing legs so they can crawl on land, and so these would be giant leaps in DNA information that would need to occur at the same time in the same place with both a male and female fish. So now they may have a way to try to explain their way around this, but I'm thinking about these big leaps in evolution that we have never observed and and we have never seen in the fossil record in some kind of transition fossil from one kind to another somewhat different kind. We don't see things that are really in between there. And so we haven't observed this. And so evolution is kind of shaky ground these days because, all right, you guys have had it well over 100 years now, 150 years or more. And where's the evidence? So you could start asking questions like that. Start questioning things. And I taught in colleges for 36 years, and what I love about colleges is that we try to teach people how to question things, not to just absorb some kind of rigid dogma that they want you to believe. Learn how to question things. That would be one way. Well, how can you go from here to here? And wouldn't that mutation have to happen in both male and female at the same time in order to keep that going? It kind of really stretches imagination, I believe. All right. So now we must concede there are a few types of fish that can live on land for several hours, even up to a few days, and they can move about on land, usually pretty awkwardly. And but there is one has been known to actually climb a few feet up mangrove trees. So I remember years ago, I think they were talking about that in South Florida, like Miami area. There were these fish that were kind of all over the place that were crawling on the land. I think they found a few of them in trees. I think, wow, okay, so there are some exceptions out there where these fish they do this, and why would they come out on land like this for a while? Well, maybe they're looking for food. Maybe they're trying to go from one puddle to the next puddle. Who knows? I mean, there's various reasons, and I'm sure the evolutionists would say, well, of course, they're evolving, and so, all right, well, now, you know, I think I've kind of mentioned this. As with all animals, there are no records of actual evolution from one kind to another, either in the fossil record or by actual observation. So, um, I'm sure that probably annoys some evolutionists, but produce the evidence. Let's see where it is. Okay, now. It's unknown, at least to me, whether fish ate other fish before Adam and Eve sinned and God cursed the earth. So we get such a bare bones outline of the beginning of Earth, the beginning of mankind, and all that stuff um, in the book of Genesis, because Genesis is not a scientific book, and God leaves it for us to figure these things out. And and there's a verse in the Bible that points to that issue, and I can't remember exactly where it is, but it's in there. Is something like it might be in might be in Psalms or Proverbs. Is the pleasure of God to create mysteries and for the pleasure of kings to sort them out or something like that. Anyway, it's a neat verse. So, in case you're a little unfamiliar with this part of Genesis, in the beginning, when Adam and Eve were created, everything was vegetarian. Everybody was vegetarian, even the dinosaurs. Even the dinosaurs. Yeah, all animals apparently can survive on 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 plant life. Okay, now I can't really prove that point. Don't have enough information, but that seems. I'm going to tilt this down a little bit. That seems to be what it might be. Um, anyway, and then that started once Adam and Eve sinned. They disobeyed God, and God, introduced, kind of contaminated the earth with sin, and God knew that the door had been opened, and it was just going to keep coming. Okay, so He cursed the earth, for reasons God knows. Okay, cursed the earth, and then animals started eating animals. And in fact, God may have killed the first animals because in His mercy, He provided animal skins for Adam and Eve to clothe themselves so they can stay warm. And so God may have killed the first animals. But anyway, um, the whole animal kingdom did not stay vegetarian, uh, you know, after that. Okay, so but were fish eating fish even before that? I don't know. I don't know. And I don't even know when the insects came about. So it's not all inclusive. What's in Genesis, the Bible is not intended to be all inclusive from any kind of scientific evidentiary standpoint. And so yeah, when did the bacteria and the viruses and the insects and what else? Um, uh, when did that all come about? I don't know. I don't know. So anyway, it's an interesting question. Honestly, I don't lose sleep on this because now fish do eat fish. And they have for at least a very long time. So all right, so there are some water life that are mammals and breathe the air, such as whales and dolphins. I think they're called cetaceans. And but they can only survive in water due to their shapes and skeletal structures. And so maybe a dolphin could survive a little bit longer on land. I think a whale would have a really tough time. How could it breathe? It just, the skeleton is not strong enough to support that big bulk of weight. I think it have a very tough time regulating its internal temperature. Whales have to be in the ocean to stay cool, and because the heat built up in a warm-blooded, in a warm-blooded whale, they have no way to get rid of that heat if they were on land. So yeah, some of these guys can't live on land, and but God created them, some animals that lived out in the water. Yeah, okay, now um, fish have an organ. I like to get into this. Fish have an organ that is very sensitive to water pressure, which allows them to live within certain water depths. And so it's like you think of the oceans as layers, and certain fish live in this layer, other fish live in this layer. Sometimes they overlap. Um, we tend to think about the fish on the top layer because we fish them and we eat them and we see them, all that stuff. But they're fish miles down that we never see, unless we send some special craft down there to have a look. The so the organ is called the lateral line. I looked this up, and it's a swim bladder, and I don't know the exact differences in these, and because I'm no expert on fish, except I do like to eat fish. So the lateral line and swim bladder in fish also allows them to track prey or avoid predators and navigate in the dark. So I thought that was interesting. I didn't know that. I learned that today, and I'm not sure how that helps them navigate in the dark. The web page I was looking at is sort of like a sixth sense, so maybe science doesn't quite understand that. But anyway, that's what I found. Okay, and but pretty cool. Now it's very sensitive to water pressure, so it would detect other fish swimming around because that movement creates a little bit of vibration. Vibration in water would be slight changes in water pressure. And so they have organs that can detect that. So they can detect movement around them, not just the depth of the water. That's very interesting. And so God had to think about this, right? When he created the fish. And there's, by the way, I'm going through this. I'm trying to hit highlights. I'm trying to keep this video under an hour. I barely made it, I think, with the last one. So it's been a good challenge for me to try to keep these, reasonably short. Um, so the so I'm not going to think of everything to talk about for fish, of course, or birds when it comes to it, but I'll hit some high spots here, hopefully, for you. Now, sea life is found at all depths. While humans can only dive several hundred feet with scuba gear, the deepest part of the ocean is 35,875 feet deep. This is in the Marianas Trench out in the Pacific Ocean. Wow, that's almost 7 miles. Okay, is that seven? Yeah, that's a little bit under 7 miles. Water pressure at this depth is about 1,072 times as much as air pressure on land. It's like 8 tons per square inch, close, almost 8 pounds per square inch. Yet there's life down there, and they live without light too. Life living without light. Okay, the actually you don't have to go that deep to lose the light. A couple hundred feet, it starts getting very dark, and I don't know when the light stops. It might be around 1,000 or 2,000 feet. You just don't see any light at all penetrating the ocean. So everything down there lives in the dark. And there are a few fish that have a way of producing light. Very interesting fish that can produce a little bit of light, and but for the most part, everything's swimming around in the dark down there. Okay, so they need that swim bladder and that lateral line to detect motion and things like this. All right. Although I'm not sure evolutionists claim that our hearing evolved from fish over millions of years of random mutations, there are very significant differences between our ability to detect minute differences in air pressure caused by sounds. So, um, what the fish detect as changes in pressure, and maybe they hear also in a way, in a rudimentary way. I'm not sure uh, if they actually hear anyway close to what we hear. But anyway, it's kind of similar, but there are big differences between how we detect minute differences in air pressure caused by sound. So on day 5, God also created the birds. Now, it took humans nearly 6,000 years to figure out how to fly. This is, of course, if you're a young Earth creationist. I guess it would take humans about maybe 300,000 years to figure out how to fly if you're um, a scientific materialist and believe that humans have been here for a couple of 100,000 years. And by the way, I've got a video there which says, can humans have really been on Earth at least 160,000 years ago? And I look at how unlikely that claim is, because that's about the youngest claim I found that Homo sapiens, us, we evolved 160,000 years ago. Some say up to 500,000 years ago. They're a hard time pinning that down. I don't want to be critical about that, but I am critical about thinking about could we really have been here this long, and there's really no record of all that. Anyway, I have a nice video on that, and if you haven't watched it, I encourage you to watch that. All right, so from the biblical view, it took humans nearly 6,000 years to figure out how to fly. Yet flight by birds is far more sophisticated. I think it is. Now, humans needed a way to propel an airplane forward so that a sufficient amount of airflow over the curved wings, wings have a little bit of curvature to them, that allows for changes in air pressure. So forward, so that a sufficient amount of airflow over the curved wings would generate sufficient lift. Lift causes the plane to go up due to differences in air pressure. All right, the Wright brothers figured all this out by 1903. And but birds, I think it's a lot more sophisticated. Let's have a look here. Bird wings must generate forward propulsion. They must be able to steer, and you must have lift through a flapping motion. And so birds can do all this stuff. It's instinctual in them. It's natural to them. They can fly, and they get very good at it. And It's amazing. I think the way the feathers are designed and things like that, and there's all these muscles inside. It's incredible. Now, hummingbirds, I love hummingbirds. They're unique in that they can fly backwards. And so, yeah, hummingbirds can actually fly backwards. I don't know of any other birds that can really do that. To my knowledge, humans have not built a successful machine with wings that flap. Okay, and that yeah, if we tried to build one, it'd probably be, I would guess, pretty inefficient. We got a great design that we built. Our wings don't flap. So now, oh, birds need to process a lot of energy in order to fly and to live within a wide range of temperatures. So God made them white, warm-blooded, unlike fish, which tend to mostly live within stable temperature ranges. So fish are, each one is adapted to a certain temperature range, and it can be down to near freezing. They can, some fish can have no problem swimming in water that is getting close to becoming ice. Yeah, they're built that way. Not all of them, and but God made birds warm-blooded because they do live in wide ranges of temperatures, and this means that, like mammals and humans, their metabolism must produce internal heat to maintain a stable temperature. So we have, of course, a fairly constant temperature, 98.6 degrees Fahrenheit, and so that's within humans. And when that gets off kilter, we have a fever, and you generally feel pretty rotten. And so mammals all have their own internal thermostat, and well, so do birds. They're warm-blooded, and that takes a lot of food to maintain a stable temperature. Now, um, birds that fly, and there are a few exceptions that don't fly, like the ostrich and the emus. By the way, one of the neater things I've seen in the past few years, I was out in my front yard, and here comes an emu down the street going 20 miles an hour. But wow, okay, you don't see that every day. Some guy had emus on his farm about half a mile away, and one of them got loose. And here comes this emu, man. He's just trucking down the road. He's staying on the road too. He's going about 20 miles an hour, my estimate. And the poor owner, the guy's in his truck with a forlorn look on his face, driving behind it, probably trying to figure out how am I going to catch this bird. And so an emu was kind of like a smaller version of an ostrich. It was it was very funny. Got a lot of local news too. It was a very funny thing. I don't know what happened if they ever caught that thing. Anyway, going back to regular birds, their thin skeletal structure must support their light weight. Birds are very lightweight, and so they can have a very thin bones, which don't weigh much. Okay, so that makes them lighter. And now, birds have a powerful digestive system that very quickly digests their food to extract the needed energy and then to quickly eliminate the waste. And we all know about birds eliminating waste, don't we? Need I say more? Okay. But they eat, they digest very quickly, they get rid of it. And so in other words, they're not burdened down by undigested food, and they get their power pretty quick. And so they're amazing that way, very amazing that way. I should say I didn't include it in the slideshow here, but the I read the other day there's some birds that can fly thousands of miles without stopping, in migration. And is the longest 12,000 miles? Anyway, something ridiculous. Like, how does a bird have that much energy to fly hundreds of miles or even a couple of thousand miles without stopping? Very, very amazing. And now it's not clear to me, can they stop, sit on the water for a little bit and rest? I don't know. Um, but they don't get to eat until they land on land somewhere else. And and birds do migrate, and so it's a tremendous amount of flying, and boy, it takes a lot of energy. So incredible. And by the way, there are insects that can do that too. That can maintain their energy flying for a long, long distance. Okay, now bird wings provide a lot of insulation to maintain internal warmth, and yeah, that helps them stay warm, and it also helps them stay dry inside too, because the water tends to not penetrate the outer layer of feathers like like ducks, for example. They don't mind hopping in a pond because most of the ducks still pretty dry. The weathers protect them. Anyway, birds eat high energy food such as seeds, nuts, berries, and insects. So, are there birds that eat leaves? I don't know. I've never seen one. Like I said, there may be a couple exceptions here and there that I'm missing. Don't, oops, my microphone. Don't get too excited about that. I'm not going to get this 100% right. I am talking in mostly broad generalities, perhaps, and there might be a few exceptions. Okay, because there's a lot of diversity out there, a lot of diversity in the animal kingdom and the plant kingdom. Anyway, they eat high energy food, seeds, nuts, berries, and insects, and because they have to keep the engine running to stay warm, keep their metabolism up, they need to be able to fly, sustain flight for quite a while. And so that's why they eat that stuff. They don't eat low energy food, be like grasses and so forth. You see this in the mammal kingdom, um, where a lot of big animals like giraffes and so forth, cows, they'll eat grasses and leaves, very low energy. The um, the ones that do eat meat, like lions, lions are kind of extreme. I've heard that a lion can eat a big meal and might sleep it off for 23 hours. Anyway, you can get into that in mathematical biology is, I think, pretty interesting. But I'm in danger of rambling and getting off topic here, so I'm going to get back to the birds. All right, so I'm just talking about some some aspects of the birds. I'm not going to think of all of them, but here's some that I find just amazing. And why is it worth doing this? It looks like I really enjoy nature, and I do. I love nature, but and so do even atheists. Many of them absolutely love nature, absolutely love it. The problem is, don't worship nature. Worship the one who made the nature. All right, who created the nature? God. That's what you. That's what's best. All right. Eyesight's highly developed in some birds, like eagles, hawks, and falcons, which is significantly better than human eyesight. Yesterday, I saw a couple of buzzards up there, about 200 feet up in the air, just floating around looking for something that's died down there. And I always look up there and say, "Do you guys know something I don't know?" Anyway, yeah, and so we have our share of buzzards or vultures, you might call them, and they must have good eyesight because they might be able to spot a mouse, a dead mouse at 100 feet, 200 feet up, where we they would get right past us maybe. All right, so the birds have voices. Okay, they can sing, squawk, screech, even imitate human voices. This obviously means they have hearing. So, on what day did God create sound? Well, it would have to be by day 5 at the latest. And it was like an old saying: if a tree falls in the forest, did it make a sound? Well, of course it did. Um, I know there's a version involving um, a husband in the woods. The husband makes a mistake in the woods, and the wife is not there. I can't remember how it goes, but it's funny. All right. What, what day did God create sound? It will be on day 5 at the latest. All right. Now, it's interesting, I think, to compare the differences between light energy and sound energy. I could talk all day about it, but don't worry, I'll keep this short. Okay. I could go on and on about this stuff. It's total fascination. I've studied, I've done calculations, things like this. Years ago, on a sabbatical, I started actually writing a book about music and math, and very, very interesting stuff. All right, well, I'll try to keep it short, on task. Now, the sounds we hear are vibrations in the atmosphere. What's this have to do with birds? Well, birds hear, and there need to be sounds, all right? Sounds are just vibrations in the atmosphere. So when I clap my hands or anything like that, you hear a sound. Now, um, I was going to play I bought this little wooden flute for 28 cents back in about 1980, and I love to demonstrate sometimes the what's called a harmonic scale in music, and where I can blow through it and hit specific notes without moving my fingers. And however, when I have my microphone set to filtering out anything that's not voice, you probably won't hear it. So I'm going to play something that to me is loud. But watch this. I don't know if you heard that. My earlier test, you can't hear it. this microphone, and it's cheap. By cheap, I mean I think I got it for 20 bucks. it it has the software, or the laptop has the software to filter out um, sounds that are not voice. So while that was loud to me, it might not show up on this video. If you hear it, it'll be very faint, maybe. Anyway, so because I wanted to do a demonstration, but I thought, well, I probably have enough to talk about anyway. So maybe someday, who knows? But sounds just we hear our vibrations in the atmosphere. I don't figure out where I was. Land animals that do hear, like us, have a mechanism that transfers atmospheric vibrations by way of a single bone, which is in birds, or several bones, in humans, for example, to an inner ear. So we have we have an eardrum, which vibrates to air pressure. It creates vibrations, or picks up vibrations, and it transfers it through the use of three bones, the hammer, the stapes, and I forgot what the other guy is called. And it somehow transfers that mechanical energy, vibrations, to the inner ear. All right, so what happens in there? This works for birds. Inside the inner ears of animals are thousands of hairs of differing lengths called cilia, little cilia, and they're differing lengths. Now, sound is generally comprised of a number of vibrational frequencies, and these different frequencies cause certain cilia to vibrate, those whose length is tuned to those frequencies. This is called resonance. So I hope that paragraph didn't sound too technical. But sound transfers from its origin and makes something else physical vibrate through the process of resonance. While in our ear, our little hairs are resonating to sounds, but only the ones that are tuned to frequencies within that sound will resonate. And so sound energy can be transferred to a solid physical object through resonance. This is how string instruments, for example, how a stringed instrument like a guitar or a violin or a double bass, they amplify, or a piano actually, amplify the small energy from vibrating wires onto a panel of wood. It kind of amplifies it and makes it so we can hear it well. All right, so that's interesting itself, but has nothing to do with birds. Okay, so the cilia transfers sound energy, when the ones that do vibrate, when a sound comes in the ear, it transfers that sound energy to the brain by whatever signals it uses. And I didn't look that up, but we have auditory nerves which are connected to our brain. And I don't know if these are electrical signals or chemical signals. I'm not sure how that works. I didn't look it up. Sorry. But that sound energy is transferred to the brain in forms of signals through the auditory nerve. Well, the sounds are interpreted by the brain. Okay. I have no clue how the brain does this. All right. Another miracle of God. He fashioned our brains so that we could, tell what sounds are. We could distinguish sounds, and we could, distinguish patterns of light on our retinas as visual images. Amazing. Now here's something that's kind of neat. If you look inside a piano, and if you have an upright piano, you just lift up the top there. If you have a grand piano, you lift up the big thing, the big top, and you'll find, I think it's 218 strings is typical for piano. I might be wrong, but I think it's 218. And 88 different lengths, all right, for the 88 keys on the piano. And those strings can function a bit like a cilia in the ear. So here's something just kind of fun to try if you're interested and you have a piano around. If you hold down the right pedal, which is called the sustaining pedal of a piano, and sing loudly into the opening of a piano, certain strings will vibrate and send their energy to the wooden soundboard. In other words, that sound energy, the vibrations in the atmosphere close to that piano, where all the strings are tied in, causes those strings to vibrate. And those strings vibrate, and that vibration is transferred to the soundboard, which is usually a very big piece of maple in the piano. And so you hear something back. It's pretty startling. I always like to play my saxophone inside of I'd honk a low B flat into the piano. I do this in classes, and you could clearly hear that note coming out of the piano, okay, vibrating. that way. So it's kind of like how our ears work in a way with the cilia. So, and I've done these calculations with resonance. It uses math that's past calculus. It's called differential equations, and it's very, very interesting results. Anyway, I think, whoops, it gets better. All right. Some birds chirp in a sort of musical manner. For the most part, birds were all created with unique voices or even songs. Now, I'm kind of going on a limb here when I'm calling in a musical manner. What is that? What am I trying to say? And that's kind of what I wanted to demonstrate with this flute, but it gets complicated trying to do this with this microphone, and so not to mess with it. Well, in 1800, Joseph Fourier, who's obviously French, is a scientist. He was actually studying heat, not sound. But he discovered a very interesting and useful pattern in endlessly repeating sound waves. Or actually, more technically, if you have a pattern, a graphical pattern that constantly repeats itself. Now, you can tie this into music. For example, if I hit the string on a guitar, the string vibrates, and the shape of the string is constantly repeating itself many times per second. All right, so it's a pattern of endlessly repeating sound waves. A Fourier series, he discovered this theorem, the Fourier theorem. A Fourier series can be used to break down these patterns into frequencies that are whole number multiples of the lowest frequency. All right, so if your lowest frequency is, we'll say, 100 vibrations per second, you'll also get 200 times per second, 300 times per second, 400 times per second, and on and on. You'll get those integer or whole number multiples of the lowest frequency. And it also calculates the relative loudness of each frequency. How loud is it? Very fascinating, I think. Anyway, so what does that mean? Well, this is how we get musical tones generated by musical instruments. Well, there's a couple of musical instruments that percussion area that just you just whack them, and they don't really produce a specific tone to speak of. But just about everything else produces a musical tone, which is just nothing but these frequencies that are multiples of one another. Very interesting. Okay, so it appears that some birds produce rudimentary tones in a physical way that has a musical tone quality. So if I go da da, that's an octave. Da 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 da. I think that's a fifth. Be like going from C to G on a piano, for example. And generally, it's fairly easy for a voice to do that because it's generally speaking a multiple of the lower note. All right. I hope this makes sense. Anyway, some birds kind of do that. You hear them singing, and I've heard them sing. They'll jump an octave or a fifth. Certain musical intervals, quite easily that way, and they get very clear sounds they put out. All right, and some birds just squawk. Okay, let's face it. But now human voices can try to approximate musicality by singing with a chest voice, a style used in opera or choral music. Like non pitre foffeloni amoroso. If I kind of concentrate my voice in my chest, I get this more of an operatic sound, and I don't pretend to even come close to that kind of quality. By the way, pop music is usually sung up here, and oh, say, can you see? Now that's not pop music, but that's a head voice. And so I love to talk about music. I'm a musician, amateur musician, amateur composer. I love to talk about that stuff, so forgive me. Now, conversationally, our voices are a large mix of frequencies, and they do not have musical quality. Okay, so we don't sing to each other when we talk. We just talk, and we don't try to produce a musical quality. We just talk. But that does allow, for the most part, our voices to be pretty unique. And so most of us, have pretty unique voices. And yeah, some people do sound like others, but that can happen. But for the most part, we sound different, don't we? All right, so birds can sing. Some just make noises, And a few kinds can talk with a human-like voice by mimicking. Well, I was listening to one the other day. I was watching a YouTube video of this bird, and that bird actually was singing. He was singing a verse, and a very nice voice too. Very nice soprano voice. Wow. And the birds have no idea what they're saying. They're just birds, but they can mimic even the human voice. And so God created these birds with all kinds of vocal abilities. Okay. So anyway, but now, by what purpose would a godless evolution through random mutations provide all this diversity? Why should birds have all this diversity in their voices? And you could say that about many things about animals and plants. Why are flowers pretty? Why are they so different? Why do we have such thousands of different flowers? This great diversity. Why are they almost invariably very pretty? How do we get pretty colors out there and things? Why are trees pretty? We consider them pretty because they have nice shapes for the most part. For the most part. And then you get into animals, and well, birds can sing. They can do all kinds of stuff like that that would not serve, as far as I could tell, any kind of evolutionary necessity. The survival of the fittest sort of idea. Like, well, the only things that really survive, what advances the survival of their species. Um, why would that happen in such huge quantities? All right, so I think we got to start asking these questions out there. Don't just take whatever science feeds you. Ask some pointed questions, and yeah, they probably have some answers. They probably do. All right, so anyway, let's kind of wrap it up here. To sum up the first 5 days of creation, God purposely created a universe supporting life that indicates intricate design in all ways. I didn't even get into what's going on in animal cells. Oh, wow. I didn't even begin to get into all that. But everything fits together in ways that provided very large diversity and even beauty. So amazing, amazing. But can a godless universe produce all that very large diversity and beauty? I would think if somehow life could originate from non-life here, and there was no God, and things just evolved by some miracle, I would think there'd only be a couple of animal species and a couple of plant species they would just dominate the earth because they would just destroy everything else. But that's not what we have, is it? Okay, so and then he even saved his best for day 6. Haha. So one more big day of creation to talk about in this series, and then I look forward to talking about other things. I'm going to very soon do a video on could humans have really lived hundreds of years? Um, Interesting question. Very good question. So we'll do a video on that soon. All right. So if you made it this far, I congratulate you. Thank you. And please like and subscribe and share all that good stuff. Write comments if you want. And I'm sure maybe sometimes a few people that hardly watch this video will put in some comments, snarky comments. Well, you're all ridiculous. Okay. Well, go ahead. Anyway, but that's when you do all that stuff, like and subscribe and all that, you help improve the algorithm for Google so that they'll try to expose more people to these videos. Okay, well, that's I think I better wrap it up for today, and it's time to roll the credits. So I hope to see you again.